Okay, so let's look at the operations, or row operations more specifically, that we are allowed to perform on matrices, which represent systems of equations. The first operation that you could perform is to interchange or swap two different rows, okay? So let's say that we had this matrix right here, and we said, you know what, I don't want this 3, 2, negative 5. I don't want that equation on top. I want the other one on top. So we could say R1, that's for row 1, swap with R2. So if we swap these two rows, we're just going to put the 1, negative 2, 10 on top, and the 3, 2, negative 5 on the bottom. Notice the notation there. It's that double arrow, and they're telling you, hey, just swap row 1 and row 2. Okay? Another operation that you could perform is to multiply a row by a non-zero constant. So let's say, for whatever reason, we wanted to multiply row 1 by 3. Okay? So we could say 3R1, stick it in row 1. Okay? And that little arrow, I always think of it as saying, oh, stick it in. Like, where do you want me to put it? So I'm going to do row 1 times 3, 3 times row 1, and stick the result in row 1. So for my scratch work, I could put a little 3 next to row 1 and picture that being distributed. So 3 times 3 is 9, 3 times 2 is 6, 3 times negative 5 is 15. And notice where I put that result, I stuck the result in row 1. They didn't tell me to do anything with row 2, so row 2 is going to stay exactly like it was, 1, negative 2, and 10. So I have successfully multiplied row 1 by 3 and put the result in row 3. Basically, that operation, why you would want to do that with matrices, that's basically what we did with elimination over here. Remember how we had the 2x plus 4y equals 6 and the x minus y equals 9? Well, we multiplied row 2 by negative 2. So even though we didn't write it using this notation over here, that's what we did. We said, hey, take row 2, multiply by negative 2, stick that result in row 2. Negative 2 times x was negative 2x, negative 2 times negative y was positive 2y, negative 2 times 9 was negative 18. So that's what we did. We didn't write it using row operations, but that's what happened. So that's all this row operation right here is doing. The third one that's going to come up is when you add a multiple of one row to another, okay? And that is going to be how we get the zeros where we want them. Remember how we said we wanted ones on this main diagonal? Ones on the main diagonal is going to come from multiplying rows by a certain number, and then the zeros will come by multiplying and then adding. So in other words, if I wanted to multiply row 1 by 2, add to row 2, and then stick the result in row 2. Okay, so 2 times row 1 is 2 times 3 is 6, 2 times 2 is 4, 2 times negative 5 is negative 10. So I've successfully multiplied row 1 by 2, and I'm supposed to add those numbers to row 2. So 1 and 6 is 7, negative 2 and 4, positive 4 is 2, and 10 and negative 10 makes 0. Now, where did I stick the result? I stuck that result in row 2. So this 1, negative 2, 10 is now the 7, 2, 0. What about row 1? Well, they didn't tell me anything new to put in row 1, so that means that the old row 1 is going to stay just like it was. Okay? So notice multiplying and then adding to a row can create a new value, and that's actually going to be how we get our zeros. Okay? All right, let's practice some row operations. They are telling us here, for whatever reason, that they want us to multiply row 1 by a half and stick the result in row 1. So I'm going to put a little half next to row 1. I'm going to distribute. 1/2 times negative 2 is negative 1. 1/2 times 4 is 2. 1/2 times 10 is 5. They didn't say to do anything to row 2, so we're going to leave row 2 exactly like it was. And this is our new matrix. Okay? Now, notice after we've applied that row operation, and we have this new matrix, now they're telling us to take row 1 and add it to row 2. So they're telling us, hey, on this last thing you found, add row 1 and row 2 together and stick the result in row 2. All right, so negative 1 plus 1 is 0. 2 plus 5 is 7. 5 plus 3 is 8. I've added row 1 and row 2. Where am I sticking it? I'm sticking it in row number 2. So 0, 7, 8 will be my row 2. They aren't telling me to put anything in row 1, so row 1 is going to stay like it was. Okay? All right? New matrix here. Notice this one is a 3-row, 4-column matrix. And they're telling us with the negative R3, they're saying, hey, multiply R3 by negative 1. Okay, so negative 1 times 2 is negative 2. Negative 1 times 1, negative 1. Negative 1 times 7 is negative 7. Negative 1 times 0 is 0. So we multiplied row 3 by negative 1. We're adding that result to row 2. So we're going to take the row 2 numbers and the row 3 numbers and add them together. And that result will go in row 2. So 2 and negative 2 makes 0. Negative 8 and negative 1 makes negative 9. 4 and negative 7 makes negative 3. Negative 18 and 0 makes negative 18. So that, remember, is row 2. They did not tell me to put anything new in row 1 or row 3, so I'm going to leave row 1 exactly like it was, and I'm going to leave row 3 exactly like it was. Okay? So that is our new matrix. Now they're telling us, okay, based on this matrix, multiply row 2 by negative 1/9. So I'm going to take a negative 1/9 and I'm going to distribute it all the way through row 2 and stick that result in row 2. So negative 1/9 times 0 is 0. Negative 1/9 times negative 9 is positive 1. Negative 1/9 times negative 3 is positive 1/3. And negative 1/9 times negative 18 is positive 2. So I multiplied row 2 by negative 1/9, stuck the result in row 2. They aren't telling me anything new to put in row 1 or row 3, so I'm going to leave row 1 exactly like it is. And I'm going to leave row 3 exactly like it is. And that is our new matrix. Okay? All right, so notice the 3 operations that you can perform, the 3-row operations. Swapping rows, multiplying a row, or multiplying a row and adding it to a different row. That's all that we can do. Okay? We are going to use those operations on our augmented matrices that represented a system of equations. Okay? Now, a couple of vocabulary items here. Our goal is to create, remember, a matrix that has 1s on the main diagonal, 0s above and below that main diagonal of 1. Once we have manipulated our matrix to look like this, we can directly read off the values of x, y, and z that make the equation come true. X equals negative 3, y equals 0.5, whatever. Okay? So we are trying to manipulate or perform row operations on our matrix to create that effect. Okay? So if you notice right here, they've done some operations to get 1s on the main diagonal and 0s below. Okay? If you get your equation to look like this, where you've got 1s on your main diagonal, 0s below, if you have a row of all 0s on the bottom, that's okay. So this one's okay with all 0s on the bottom, but they've got their 1s on the main diagonal and any 0s are below. Okay, that is called row echelon form. Okay, if you take it a step further and get 1s on your main diagonal, 0s below and above, okay, you've completed what we call reduced row echelon form. That is the one that we typically prefer. Okay? Notice Gaussian elimination, fancy words after a man named Frederick Gauss. Okay? Gaussian elimination, okay, allows you to convert to row echelon form. Okay? Gauss-Jordan, another mathematician named Jordan, said, hey, you know what? Gauss did some good work by getting these 1s on the main diagonal and 0s below, but if we take it a step further and get 0s below and above, that's even better. So Jordan added some to Gauss's work and converted to reduced row echelon form. Typically, I prefer reduced row echelon form with the 0s above and below. It doesn't take much more work and makes it a little easier. Okay? So notice once you get it to this form, in this case we could say, oh, x is 12.6, y is negative 4, z is negative 3.8, and you're done. If you leave it in this format, you can see what z is. You can say, oh, look, z is 1/2. But right here we've got a y and a z. So this one right here is saying, well, y plus 4z is negative 8, and you would have to do a little more work. Now we know z is 1/2, so you could say, okay, well, y plus 4 times 1/2 equals negative 8, and you can figure out what y is worth. But it takes a little bit more work because you have to do some more substitution. So there's nothing wrong with row echelon form using Gaussian elimination, but I prefer to use the Gauss-Jordan and get all my zeros so I can just read directly what the values are for x, y, z. Okay? Notice if we've ever have rows that have all zeros, those are on the bottom. And that's okay too. We'll talk in 6.2 about what that means, but that's okay too. All right, so remember we're going to do some row operations to convert from a messy matrix, like maybe this one, use row operations to create one that looks like this, okay? And we talked about what those operations were, okay? All right, so we're just going to kind of follow this flow here, and this one that's already worked for us so that we can see what they've done, and that will help us figure out the system and the procedure, okay? All right, so our procedure for converting to reduced row echelon form. We always start with the left column. So this column that has the 2 and the 1, that's going to be where we start. We are going to make this column look like what we want it. What do we want it to look like? We want a 1 on the top and a 0 beneath it. So notice how the first thing they did was, they changed this 2 to a 1. And then they said, okay, I need zeros below it, so I need this 1 to become a 0. And then that first column was done. And then we move over to the second column. And after you finish the first column, then you go on to column 2. Within the column, your first objective is to get the 1, and then you get any zeros. So notice they needed a 1 in this top left corner, so that's what they did first. They got that 1, then they got the 0 where they needed it. So now that we're in column 2, 1s are our main priority, so we're going to get this negative 3 to become a 1. And then we'll get our zeros. So we need that 2 to be a 0. Once you've done that, you've got your first column done with a 1 in the top and a 0 on the bottom. Then you get your next column where you've got the 1 on the bottom right and zeros above it. And then whatever you read off should be your answer. So this answer would be x equals 7, y equals negative 2. Notice that's the same exact system of equations that we started with a while ago when we did our substitution, elimination, and graphing. That was the exact same system of equations. So you know that answer is correct. It's the same one. Okay, let's talk about what all this stuff is over here, what the operations were that they did. Well, remember, first goal in the first column is to get the 1 where you want it. Now, probably I could have picked a different example here, because one way that we could get the 1 in that top left corner is by switching or swapping those 2 rows. Remember, a while ago we said you could do R1 interchange with R2. So that's what we could have done, but usually if you see that you could have done a row swap, usually you do that swap when you write your matrix down at the very beginning. So I'm going to bypass that right now and just say, oh, I forgot, man, rats, I already put it in. Oh, well, we'll use this one, okay? And by put it in, I mean you've already put it in your calculator, you've already set it up, okay? So usually if you notice, rows can be swapped, to do that first, but we forgot here, so we need this 2 to be a 1, okay? So notice the little trick here. To get your 1 in a column, multiply the row by the reciprocal, okay? So in other words, I want this 2 to be a 1, so I can multiply this 2 by 1/2. 1/2 times 2 would make the 1. But I can't just multiply one number, I have to multiply the whole row. So the row operation I'm going to use is 1/2 times row 1, and stick the result in row 1. So when I distribute my 1/2 right here, 1/2 times 2 is 1, 1/2 times 4 is 2, 1/2 times 6 is 3. So that's where that 1, 2, 3 came from on the top row there. Notice the bottom row, nothing has happened, nothing has changed. Once you get the 1 where you want it, then you get your 0. So notice they say to get your 0, multiply the row with the 1. That 1 that we just created, that row is what we're going to multiply by. And we're going to multiply it by the opposite of whatever we're trying to get rid of. Okay, I'm trying to get rid of a 1. Opposite of 1 is negative 1. So I'm going to multiply this 1 right here. I'm going to multiply that whole row by negative 1. Because negative 1 times 1 makes negative 1. And when I add it to this other row, I'll get a 0. Okay? So we're going to say, okay, row 1 gets multiplied by negative 1, and that result gets added to row 2. Okay? So this is kind of not lined up very good. Sorry about that. But when I multiply my row 1 by negative 1, negative 1 times 1 is negative 1. Negative 1 times 2 is negative 2. Negative 1 times 3 is negative 3. So I've multiplied row 1 by negative 1. I add that result to row 2. Row 2 had a 1, a negative 1, and a 9. And when I add those together, negative 1 and 1 make 0. I knew it was supposed to be a 0. That's why I picked that. Negative 2 and 1 makes negative 2 and negative 1 makes negative 3. Negative 3 and 9 makes 6. So 0, negative 3, 6 is going to be my new row 2. Okay? I am done with column 1. I have the 1 where I want it and zeros everywhere else. So I move on to column 2. Remember, within the column, get your 1 first. Where do we want the 1? On this main diagonal. So I need that negative 3 to become a 1. What can I multiply so that I'll get a 1? Well, negative 3 times negative 1/3 would make a positive 1. Okay? So remember, multiplying by your reciprocal is how you get your 1s. So they're saying, hey, the row operation is negative 1/3 times row 2. Stick it in row 2. Okay? Negative 1/3 times 0 is still 0. Negative 1/3 times negative 3 is positive 1. And negative 1/3 times 6 is negative 2. That's how we got the 1 in that spot right there that we wanted. The last thing we have to get rid of is the 2. We need that 2 to be a 0. Okay? So remember, to get a 0, multiply the row with your 1, so row 2, multiply it by the opposite of whatever you're trying to get rid of. I'm trying to get rid of a 2. So I'm going to multiply this row right here by a negative 2, because negative 2 times 1 is negative 2, and negative 2 and 2 will cancel out and make a 0. Okay? This 1 right here that I'm multiplying by, we call that the pivot. So always get your 1 first in each column, and we call that the pivot, because that's the number that you're going to multiply by. Okay? All right, so notice I need to multiply this row 2, the row that had the 1 in it, by negative 2, by the opposite of whatever I'm trying to get rid of. I was trying to get rid of a 2, so I multiply my 1 row by negative 2. So negative 2 times row 2, add the result to row 1, because I'm trying to get rid of that 2 that's in the row 1. Okay? All right, so negative 2 times row 2. Negative 2 times 0 is 0. Negative 2 times negative 2 is positive 4. Negative 2, oops, sorry. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4. Okay, so that's the multiplying part. I'm adding that result to row 1. Row 1 had a 1, 2, 3. When I add them together, 1 and 0 makes 1. Negative 2 and 2 makes 0. 3 and 4 makes 7. So that's the new row. And where am I sticking it? Oh, I'm sticking it in row 1. So that 107 goes in row 1. My row 2 stayed at 0, 1, negative 2. Okay? Now I can read off here, x is 7, y is negative 2. Okay? All right. That takes a little practice. So what we'll do is let's try one together. Okay? Please pause the video, rewatch as you need, so that you can be confident in the system, the process here, okay? All right, so first thing we need to do, here's our system of equations. We need to get them in standard form so that we can write our augmented matrix. Top equation looks good. 2x plus 3y equals 7, that looks good. Bottom equation, when I distribute the 3, 3x plus 3 equals 5y plus 4. Okay, the issue we have here is our y's are on the wrong side, so I need to bring those y's over. They'll become negative when I bring it over. And that 3's on the wrong side. It needs to move over to the right, so I have to subtract 3 on both sides so that it can come over here with the 4. All right, so when I do that, I'll have 3x minus 5y. Okay, and the 3 comes over here, subtract 3 from both sides, equals 1. So this is what our equations need to look like, where x's are lined up, y's are lined up, equals, and our plain numbers. Once we have it set up that way, we can write our augmented matrix. So 2, 3, 3, negative 5, 7, 1. That's our augmented matrix. That's the matrix that we're going to perform some row operations on. Okay? All right, so I'm going to write that matrix down. There it is. And now I'm going to do some row operations to convert it to that standard, to that reduced row echelon form. Remember, reduced row echelon form has 1s on the main diagonal, so where the 2 and the -5 are, we want those to be 1s, and 0s above and below. So where the 3s are, we want those to be 0s. Remember, we start with column 1 first, so we're focusing mainly on this 2, 3 column. Get the 1 first. So where that 2 currently is, I want it to be a 1. So what can I do to row 1 so that that 2 will be a 1? I can multiply by a half, because 1/2 times 2 will make 1. So 1/2 times row 1, and I'm going to stick the result in row 1. Okay, so scratch work here. 1/2 times 2 is 1. 1/2 times 3 is 3/2. 1/2 times 7 is 7/2. Nothing's happening to row 2, so it's going to stay 3, -5, 1. Okay. I need you to show on your paper, I need you to show the row operation and the resulting matrix, okay, for each line. Okay, we got our 1 where we wanted it. Now we need to get 0 beneath it. So what can I do to get that 3 to become a 0? Remember, once you get your 1, we call that the pivot. That 1 is called a pivot. So I need to multiply my pivot row, which is row 1, by the opposite of what I'm getting rid of. I'm getting rid of a 3. The opposite of 3 is -3. So if I multiply row 1 by -3, 1 times -3 is -3. Will that -3 cancel with +3? It sure will. So I want to multiply my row 1 by -3, add that result to row 2, and stick that resulting row in the row 2 position. All right, so let me get a little pencil here for some scratch work. -3 times 1 will make -3. -3 times 3/2 will be -9/2. -3 times 7/2 is -21/2. Okay. Multiply. Now I need to add and stick the result in row 2. So 3 and -3 makes 0. That's going to be the bottom number in row 2. -5 and -9/2. We'll see. -9/2 is, let's see. Let's use our calculator here. -5 plus -9/2 is -9.5. So you could call it -9.5. You could call it -19/2 if you wanted. That'd be fine as well. And then 1 and -21/2 is also -9.5. Okay, that's our row 2. Our row 1 is going to stay as 1, 3/2, 7/2. Okay. All right, column 1 is like we wanted. It's got the 1 and the 0. Next, we need to get rid of the -9/2. We need it to be a 1. And we said that, remember, -9/2, let's see, is what, -19/2. 19/2 would be 9.5. Okay, so to get your 1, multiply that by the reciprocal. The reciprocal of -19/2 is -2/19. Okay, so -9/2 times, -19/2 times -2/19 will make a +1. So I'm going to multiply by the reciprocal. Reciprocal of -19/2 is -2/19 by row 2. Stick that result in row 2. Okay. So my top row will stay 1, 3/2, 7/2. 0 times -2/19 is 0. -2/19 times -19/2 is +1. And then let's see, -2/19 times -9.5. Oops. -2/19 times -9.5, left out my point there, is +1. Okay. All that's left to get rid of is this 3/2. Okay. So the 1 beneath it is our pivot. So we multiply our pivot row, the row 2, by the opposite of whatever we're trying to get rid of. We're trying to get rid of 3/2, so we'll multiply by -3/2. Okay? Because 1 times -3/2 is -3/2. That will cancel with the positive 3/2 here. So remember to get your 1s, multiply your pivot row, the row here that had the 1, by the opposite of what you're trying to get rid of. So -3/2 row times row 2, add it to row 1, and stick the result in row 1. Okay? When I do that, hi, I'm filming a video if you don't mind, if you have a second.
Okay, I was just checking projectors.
We're working awesome. I'm sorry to bother you.
Well, no, yeah, just making sure they're shut down.
Yeah, I'll shut it down when I'm done. Thank you. Okay, so we'll multiply -3/2 times row 2, add it to row 1, and that result will go in row 1. Okay, so -3/2 times 0 is 0. 0 plus 1 is still 1. -3/2 times 1 is -3/2. -3/2 plus 3/2 is 0. -3/2 times 1 is -3/2. -3/2 plus 7/2. Uh-oh, let's see here. -3/2 plus 7/2 is 2. So that's, the top one will be a 2, and then we'll keep our 0, 1, 1 on the bottom. And we can read our results off. They're saying 1x equals 2, so x is 2, and 1y equals 1, so y equals 1. So that means that the ordered pair 2, 1 would be the solution to this system of equations. Okay, now I realize it probably would be faster to have used substitution or elimination or one of those guys, okay? But when we get to 3 variables, that's not necessarily the case, so we want to get comfortable with that. Okay, let me show you in the row ops program that we put on your calculator how that would look, okay? Because the tedious part of this, after you get a little bit better at it, the tedious part is not finding the row operations. The tedious part is doing the math. And so your row ops program will do the math for you if we can just tell it the row operations to perform, okay? So we need to put this matrix in. So we'll go to second matrix. We'll edit our matrix. I'm going to pick matrix A, which is a 2 by 3, and I'm going to fill in my numbers. So 2, 3, 7, 3, -5, and 1. Okay, that's our matrix A. I'm going to exit out of editing my matrix, and I'm going to go to the row ops program. I'm going to hit the program button. I'm going to execute, and it's saying, oh, you want me to do the program row ops? And I say yes by pressing enter. And it's going to say, okay, where's your matrix? And my matrix was A. That's where I put my numbers a while ago, so I'll pick number 1. And it's saying, okay, I'm going to check this for you. Is this the matrix that you wanted? So this would be my opportunity to say, yep, that's right. Or if you made a mistake, you could exit the program and go back and fix your matrix. Okay, so I hit enter, and it's saying, okay, here's the row operations that I can perform. I rarely pick row swap because I try to take care of that before I put in the matrix if I think I need to swap anything. I don't think I've ever picked option 2 for just adding rows together. So I'm always going to pick either 3 or 4. Okay? Remember the first operation, the first thing we need to do is get our 1s. So what do I need to do to get a 1 where this 2 is? I need to multiply by 1/2. So I write down the row operation I'm going to perform. I'm going to multiply row 1 by 1/2 and stick in row 1. So which operation is just multiplying? That's option 3, just to multiply a row. So I'll pick option 3, and it's going to say, okay, you want to multiply row what? I wanted to multiply row 1. So I say 1 and press enter. By what number? I wanted to multiply by 1/2. So I can type 1/2 or type 0.5. And it says, okay, here's your new matrix. Notice that's the exact same matrix that we got when we did it by hand, but we didn't have to do all the work by hand. See how that's better? Okay, so now it's saying, okay, this is what I got. So your calculator tells you what the new matrix is. We could have just written this by hand. Okay, press enter, and it's going to say, okay, what operation do you want next? Well, remember the next thing we needed was to get rid of this negative, or was to get rid of the 3. And we wrote down that -3 times row 1, because our row 1 had our pivot. So row 1 times -3, 1 times -3 makes -3. That cancels with the positive 3. So when we want to get our zeros, we're going to pick option 4, multiply a row and add it. So option 4, we're going to multiply row, and this is why I use the row operation I wrote down. Multiply row 1 by -3 and add to row 2. And it should do it for me. Notice it already wrote them in fraction form for me, so I don't have to do this decimal to fraction conversion. It's going to give it to me in fraction form and save you from having to do all that number crunching. Notice column 1 is good, had the 1 and the O. Now I'm ready to deal with column 2, and the first thing I need to get is my 1. Remember, to get your 1, multiply by the reciprocal. So the reciprocal of -19/2 was -2/19. That's why we multiplied row 2 by -2/19. I press enter so that I can get my choices for row operations. To get your 1, pick option 3, which was just multiply the row. We multiplied row 2 by -2/19. And that's exactly what we got when we did it by hand. Okay. Last thing we need to get rid of is this 3/2. We need this 3/2 to be a 0. Remember, to get your zeros, you multiply and add. So we use your pivot, the 1, use the pivot. Multiply that pivot row, row 2, by the opposite of what you're trying to get rid of. We were trying to get rid of 3/2, so multiply by -3/2. And add that result to row 1, just like the row operation was we wrote down. So press enter. That's option 4, multiply by row and add. We multiplied row 2 by -3/2 and added to row 1. And there's our new matrix. That's what we got when we did it by hand. Okay, so notice that the calculator program, the row ops program, just does the number crunching. You still have to come up with the row operations yourself, but it will do the number crunching for you so that you can get this last answer. Okay, let's talk about what I need to see on your paper. When we have a test, I will give you a system of equations or a matrix, or I may give you the system and ask you to create the matrix first. But once you have your matrix, you'll write that down. You'll write the row operation. You can use your calculator to perform the row operation, but write down what you get. Then write down your new operation, let the calculator perform it, and you write down your new matrix. Write down your next row operation, let the calculator do it, write down the next matrix you get, and so on. Okay? So I know you're using your calculator to perform the row operations, but you're writing down each step along the way. Okay? All right, let me show you one other thing. Let's say that you make a mistake, and you say, oh, I want to multiply row 2 by 7. It's going to do that for you. Notice it's messed it up. I didn't want a 7 there. I wanted a 1 there. Okay? So if you mess up, you're kind of stuck. So what you do is you exit the program and you go back to the last good matrix you had, and you enter that last good matrix in matrix A, and you carry on from there. Okay? There's not a back button once you're in the program, to say, oops, I messed up, back me up. It doesn't have that. So that's why you're writing down the new matrix each time, so that if you make a mistake in your calculator, you can exit the program, type in the last good matrix as matrix A, and carry on from there. Okay? All right. What do we do now if we're done? Okay, so I'm done with that program. I want to do just some regular computations. I need to exit the program. So have you noticed how, as we come up with the different row operations here, option 5 is quit to main. That means quit the program and go back. So I'm going to pick 5, and it's saying, taking me back to the home screen in the program, where option 6 says quit, and now I'm out of the program. So now I can do my regular computations, 8 times 3 or whatever I need to do. Hopefully you're not doing basic multiplication, but you can go back to your home screen, your calculator, and do math. Okay? We will practice this program some more, but hopefully that helps. Hopefully you also noticed that there was an optional printing for 6.1, and it is how to use the row ops program. And it takes you through a couple of examples and reminds you what to write down along the way each time, and shows you what the calculator will say. So I encourage you to use that to help you with your row ops program.